Okay. Um, okay, we start the topic five. Topic five. Okay, 5.1. The four basic assumption of kinetic molecular theory of gases of an ideal gas. That's four. Volume of the gas is negligible compared to the volume of its container. The average kinetic energy of gas proportional to temperature of gas. The intermolecular forces between the gas molecule is negligible. The collision between gas particles are elastic. The gas law. There's three types of gas law: Boyle's law, Charles law, and Avogadro law. So when pressure increase, volume decrease. So the formula is P1 V1 equal to P2 V2. Charles law, the pressure is constant. When the volume is increased, the temperature also increase. So the formula is V1 over T1 equal to V2 over T2. Avogadro law, the pressure is constant, the volume is increased, the number of mole is increased, and the temperature is constant. So the formula is V1 over N1 equal to V2 over N2. So the mathematical formula. So for Boyle's law is uh, V constant to 1 over P. Just continue. So you can see the graphical intersection, the graph lah, the graph. Ni P or P again V, P again 1 over V, and a constant graph. And this for V against T, it is over V against T when the T is negative 273.15, and this is a normal V and V again. And so for definition of ideal gas, gas that will obey all gas equation. So the ideal gas equation is PV equal to nRT. So relation of ideal gas with molar mass, and definite density of gas is PV equal to nRT, and number of mole is mass over molar mass. So we can put it to the question. So it can be PMR equal to mRT over V. So the the formula of density, P equal to PMR over RT, and the molar mass, MR, equal to density RT over P. So particle pressure of gas, PT equal to PA plus PB. PT is NT RT over V. And Dalton's law of particle pressure. Definition: the total pressure of mixture of non-reacting gases is the sum of the particle pressure exerted by each of the gases in the mixture. So the formula is also PT equal to PA plus PB. The same as PT equal to NART over V plus NB RT over V. And this is the difference between ideal gas and non-ideal gas. So the volume for ideal gas is the volume gas is negligible, and non-ideal gas is the molecule not negligible and have certain volume. Active force, intermolecular force between gas molecular are negligible. There are force between molecular gas. So equation PV equal to nRT. So for the non-ideal gas is P plus N2A, and the power of 2 A over V the power of 2 V square lah to multiply with V minus NB equal to nRT. There's no intermolecular force for ideal gas and molar volume. So the intermolecular forces for non-ideal gas is N square A over V square is used to correct real gas pressure to include attraction. Molecular volume using NV to consider volume of gas moleculars. So the low pressure for ideal gas is when gas molecular do not occupy the sizable. So the intermolecular force are now become negligible. So high temperature, the kinetic energy of gas molecular increase. The molecular have more energy to break away from their mutual attraction. For non-ideal gas, high pressure, when a gas is compressed, volume container decrease. Gas molecular now occupy sizable portion of the container. So for low temperature, the kinetic energy of the gas molecular decrease. The molecules have less energy to break away from their mutual attraction. And now for 5.2, siapa?
Aku.
Okay, silakan. Nampak tak?
For properties of liquid, shape of molecules affects its chemical physical properties. The description is particles arranged closely, and then the intermolecular forces not strong enough to hold the particles firmly in place, thus the liquid fit the shape of its container. For the example is cubic box. And then for volume, the amount of space the substance or objects occupies. The description is volume is fixed. The example is a graduated cylinder to measure volume of a chemical. Diffusion. Jangan gerak. The movement of a substance from an area of high concentration to an area of lower concentration. Description: molecules are closely packed and lower kinetic energy because stronger intermolecular
Attractive.
intermolecular
Attractive.
attractive forces between the molecules compared to gases. Daily life, the smell of perfumes. And then for viscosity, a measure of a fluid's resistance to flow. Viscosity depends on size of molecules, increase more resistance to the flow. And then second, stronger intermolecular attractive forces. Dah hilang.
Hilang.
Tak. Stronger intermolecular forces, more viscous. Example dia honey.
Ya, okay.
Kayak racun kotak.
Okay, next.
Compressibility, the proportional reduction in the thickness of a material under prescribed condition of increased pressure of compressive. Description dia, particles are packed closely, have very little empty space, thus it is difficult to be compressed. Example, liquefied petroleum gas, Dapo gas. For surface tension, the energy or work required to increase the surface area of a liquid due to intermolecular forces. Description, the stronger the intermolecular and attractive forces, the higher the surface tension. For example, adding detergent to water decreases its surface tension. Definition for vapor pressure is pressure exerted by vapor molecules above the surface of liquid in a closed container. For boiling point, the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. Factor that influences the rate of evaporation, temperature, intermolecular forces, and surface area.
Nampak kan?
The relationship between intermolecular forces, vapor pressure, and boiling point. Weak intermolecular forces very loosely held together and have weak attraction with one another. Strong intermolecular forces every attach one another and tightly held together. So for vapor pressure, higher vapor pressure, a fuel will not have enough kinetic energy to escape of given temperature. And lower vapor pressure, a fewer molecules will have enough kinetic energy to escape at given temperature. For boiling point, lower and higher. And then phase change. For the process melting, phase change dia solid to liquid, temperature increase, and then kinetic energy increase, and motion or movement of molecules faster. So intermolecular forces decrease, conclusion dia higher. For vaporization, liquid to gas, temperature higher, increase, kinetic energy increase, motion of movement of molecules faster, intermolecular decrease, conclusion vapor forces.
Bukan.
Ha?
Semua ni. Sekali-sekali.
Sekali-kali.
Sekali.
Lepas tu sublimation, phase change dia solid to gas. Senang cerita semua tu temperature dia increase, kinetic energy dia increase, motion of movement of molecules faster, intermolecular forces decrease. And then condensation, gas to liquid, freezing, liquid to solid, deposition, gas to solid, temperature increase, kinetic energy, salah, temperature decrease, kinetic energy decrease, motion or movement of molecules getting slower. So, itu apa?
Apa dia?
Ke atas kan?
Apa dia?
Ke atas kan?
Mana?
Intermolecular forces increase. So, lower vapor forces. Dah. Oh, ada lagi kat bawah tu.
Ni tak payah
Tu.
gambar je.
Okay. Okay.
Solid. Siapa? Fatih? Ke?
Aku.
Tati.
Okay.
Bukan di atas lagi ya?
Solid.
Oh betul.
Atas sikit. Okay.
Okay, yalah. Untuk phase shape of solid.
Tiba.
Stretch of interpartial force strong. Arrangement of particles closely packed together and in orderly arrangement. For molecular motion, vibrate and rotate about fixed position. And for shape and volume, has a fixed shape and volume. Apa-apa.
Nampak?
Okay. Nampak. Types of solid. The solid divide by two. Crystalline solid and amorphous solids. For arrangement of particles, aku cakap crystalline solid dulu tau.
Boleh.
Okay. Untuk arrangement of particles, the particles are arranged in a regular, apa tu? Repeating arrangement and have well-defined structure. For amorphous solids, the particles are arranged random arrangement and have no well-defined order structure. For physical properties, for crystalline solids have shape and well-defined melting point, and for amorphous solid have no defined melting point and melt over a range of temperature. Formation for crystalline solid form when a saturated liquid is cooled slowly, and for amorphous solid form when a saturated liquid is cooled rapidly. Example for crystalline solid are salt, diamond, and sugar. And for the amorphous solids are plastic, glass, and rubber. Okay, types of properties of crystalline solid. Types for iconic solid, the description is consists of ions, positive and negative ions that held together by ionic bonds. For example, is NaCl and KBr. For molecular covalent solid, composed of molecules held together by intermolecular forces such as van der Waals and hydrogen bonds. For example, H2O and I2. Giant covalent solid, large molecules that compose of atoms linked together by covalent bonds. For examples, diamond and graphite. Metallic solid has a closely packed structure and composed of atoms of the same metal linked together by metallic bonds. For examples, sodium and magnesium. Okay, comparison of the properties of solid, liquids, and gas. For solid, the position is too close for each other. And for liquid, they have quite close among of them, and for the gas, they have more space among them. Sekejap ke aku nak cakap satu-satu?
Just teruskan sekali.
Cakap solid dulu solid dulu.
Solid.
Gitu.
Boleh.
Okay. Untuk solid, shape and volume has definite shape and volume. For arrangement and particles, close together and in orderly arrangement. Molecular motion vibrate about fixed position. Interparticles bonding of force for solid very strong. Compressibility for solid very low. Surface tension for solid very small. Viscosity for solid none. Diffusion of solid very slow. Shape and volume for liquid has no definite shape but has definite volume. Arrangement of particle for liquid close together but not rigidly arranged. Molecular motion for liquid slow. Interparticle bonding or force for liquid is strong. Compressibility for liquid low. Surface tension for liquid is significant. also to viscosity is significant. Diffusion for liquid slow. Dekatkan sikit.
Yang mana? Oh ya. Hmm,
Yang gas.
ya.
Okay. Untuk shape and volume for gas has no fixed shape or volume. For arrangement of particles for gas or apart from one another with random arrangement. Molecular motion for gas randomly and rapidly. Molecular motion for gas weak. Interparticle bonding of force is high. Interparticle bonding of force weak. Compressibility for gas high. Surface tension for gas none. Viscosity for gas high. Diffusion for gas fast. Okay dah.
Okay. Fatih.
Test.
Okay.
For phase diagram, the term phase, the definition is a homogeneous part of a system which is separated by a distinct boundary such as solid, liquid and gases. For component, a chemical species of phase that can exist independently. For triple point, the point at which the three phases, iaitu solid, liquid and gas, can coexist. For critical point, the point at which there is no boundary between the liquid phase and gas phase. For isobaric, the change in temperature at constant pressure. Isothermal, the change in pressure at constant temperature. So untuk drawing the phase diagram, first kali kena title, pattern, lepas tu y axis, pressure, x axis, temperature, phase dengan triple point and critical point. Lepas tu drawing dia macam tu lah jadi dia.
Okay. Tahu, buruk
that's-
tahu.
Macam tu lah jadi dia.
Okay. Okay.
So explanation, line DB slopes to left, negative slopes, DB tu. Lepas tu the melting point of ice decrease with pressure. At high pressure, the position of
Equilibrium.
equilibrium shift to the right. Increasing in pressure will cause the volume to decrease and makes the ice easily melt at high pressure. So, solid melts at lower temperature and high pressure. Lepas tu bawah tu apa tu?
At 1 atm.
At 180 m.
At 1 atm, the temperature at which ice and water at equilibrium is called normal melting point, iaitu 0 darjah Celsius or 273 Kelvin, 0.15 Kelvin. So untuk phase diagram H2O, macam tu lah dia punya drawing.
Sudah.
Buruk.
Explanation dia, line AX slopes to the right, positive slopes. The melting point of CO2 is increased with increasing of pressure. Increasing the pressure forces the particles in the solid to be even closer together and higher temperature is needed to melt the solid.
Okay.
So bawah ni kena baca lah.
Boleh kot. Baca.